Alright, two ways to do this. Let me show you the first way first, which none of you actually use. Okay, all of you use the cases way, which is fine. But it's a bit problematic, which I'll explain later. Okay, why? Because you will actually get the answer if you miss out some cases. That's the funny thing, right? You actually miss out some cases, but you still get the answer. So one of the best way to do it is using this other way that none of you were thinking about. Okay, so let me show you quickly. All right, now exactly two letters the same or two digits the same, but not both. Now I don't know about you, but this sounds a bit like A or B, but not both. Okay, and this kind of question is not uncommon in A-levels. This is 2013, right? 2013. I think just the year before this, there was another one which is something in the same side, but it's not digits and all. It's like brother or sister one. So it's A or B or both. Then the next time it come up was A or B, but not both. So if you think in terms of that kind of question, A or B or both is like A union B. Okay, so A or B or but not both is like A union B, but minus away the intersection. So if you frame it in a set way to do it, it's probably a bit easier, a bit lah. Let me show you quickly, okay? So you let event A be the event that exactly two letters the same. Okay, so that shall be your event A. Okay, your event B be exactly two digits the same. That's your event B. Not both. Both means what? Event A and B, right? So your A intersect B, but that one later. Let's just sort out this one first, okay? So exactly two letters the same. I don't care about the digits. So two letters the same. Think about it, guys. There are 26 letters. You're looking at, sometimes it pays to visualize. What do you mean by two letters the same? You draw it out. What do I mean? It probably looks a bit like this, right? XXY. Okay, again, I don't care about the digits because case 1 is basically just talking about this. So you make sure your A and B, they are very clearly defined. Okay, so it's just this. So basically, when you have two letters the same, you still need two different letters. Agree? You need the X and the Y, right? To form the XXY. Follow? So you realize that you need this. 26 choose 2. You need to choose two letters first, okay? To make up your X and the Y, for example, like this. So it could be AB, it could be AC, it could be AX, AZ, whatever, or in this case, XY. Okay, all counted inside. But let's think, guys. Let's say the pair is XY. Must it be XXY? Can it be XYY? It can be XYY, right? So just the XY alone, all right, so you realize this 26C2, there's a case of XY, there's a case of AZ or whatever, right? All the different cases. But just this case alone, you realize it can be XXY, it can be XYY. Make sense? So 26C2, well, not going to do it. You need to times 2. The times 2 is not that you are going to permute the XYY is X, but it's to see the XXY, XYY. Are we all clear? Okay. Next. Once you get the XY, XXY, then you realize that it may not be XXY, right? It may be XYX, YXX, and so on. So you need to permutate the three letters with two repeating ones. Make sense? That explains this part here. I don't know, one of the numbers that went missing. Okay, but anyway, your case is a bit different because you have the digits at the back. Okay, so but anyway, are we all clear about case 1? Or rather, not case 1. This is event A. Exactly two letters the same. I think we cover everything already, right? So that will be 26 cube. That's the probability of your event A happening. Exactly two letters the same. Next. Exactly two digits the same. So again, visualization does help, right? Two digits the same, we're talking about 1, 1. Wait a minute. It could have been 2, 2. It could have been 3, 3. 4, 4, 5, 5. It's actually quite easy, right? 9, choose 1. Right? Only 9 possibilities, right? Choose 1, divide by 9 squared. Well, it's essentially just 1/9, really. Okay, so that's the probability of event B happening. Okay, now, both. I need to figure out what's both. Both will be A intersect B. What is A intersect B? Well, of course, by the definition of my A and B, A intersect B must be exactly 2 letters the same and exactly 2 digits the same. So what is the visualization again? Well, it looks a bit like this. Something like this. Okay? So this is the A intersect B, which is overlap, what they are overlapped with. It would be something like that, right? The x, x, y, 1, 1, and that's what you actually don't want, but we don't really care because the moment we frame it in event A, event B, we're going to just use the set formula to help us. Okay? So how do we find this probability x, x, y, 1, 1? It turns out it's a combination of some of this, but basically the hard part has been thought through already. So let's think about the latter part, which will be this. It's still the same, huh? Okay? And then the digits must be 9 choose 1. Right? And divide by 26 cube times 9 square. So what we want, if you think about it, right, what we want is actually inside A, inside B, but not both. Okay? So this is the Venn diagram representation. So you realize that it's actually just the whole peanut minus away the intersection. In some sense, if you think about it, what you want is actually the probability of A plus the probability of B minus away 2 times the probability of the A intersect B. Make sense? Because if minus away 1 time, you get the peanut what? But it's not really quite the peanut, right? You need to minus away 1 more time so that you get the empty in the middle. Add, subtract 2 times. Because you make it, I won't say you simplify it, but basically you make it like event A, event B, event intersect, and then you realize that you just follow through this so-called formula. I don't know whether you find easier or not, but basically the events are probably a bit easier than the cases. Okay? We'll talk about the cases as well, but then I also want to talk about that one separately because that one interesting. So let's try to solve the answer first. Okay, it can be quite annoying to type in the calculator. So let me just very quickly, if you have very fast fingers, please help me out and also check. Okay, I'm going to key in just 26p2, shortcut, and then times 3. Okay, so there you go, this is it, right? Times 3. Divide by 26 cube. Okay, so this is the answer. Yucks, I don't like this. Okay, 1109,467. Okay, I think that's enough DP already. Okay, all right, 1 over 9. Okay, that's easy. Let's. Oh, okay. So this one is done. This part, right? I calculated this part already, right? So I just have to times another 1 over 9. Okay, right. For the so yucks. Okay. 0, 1, 2, 3, 2, 7, 4. Okay. 0, 1, 2, 3, 2, 7, 4. All right. So according to what I should be finding, this one I need to times 2, right? So I'm going to take 0.1109467 plus 1 over 9, right? Minus 2 times the answer that I got previously. 1974029. Okay, 1974029. I think I can't remember phone numbers for this particular reason. 98. Okay, let's be more kiasu a bit. All right, so 3SF, you get 179, which is the correct answer. That's cool. Okay, we got your correct answer. Now, I went around. I saw nobody actually did it this way. So I want you to see that, hey, yeah, I could have done it this way. All right, I would think that this one has a bit of advantages versus the cases. I think because the cases are easier, right? Event A, you define it well, you make sure you define it well, because these are not really cases. It's like event A, what is it? Event B, what is it? They can overlap one. Cases are not overlapping, right? So it's completely different view. And this one is a lot relying on what we call the sets to help us. So far so good? Okay. How about the cases? Wait, now, okay, I need space, right? No space. Okay, let me just copy and paste this question elsewhere. Okay, here we go. All right. bear in mind the answer. 197. Okay, so that's the answer. Let's try to think about the cases. So many of you managed to figure out some of the cases, which is cool. Let's talk about the first two that usually people can think of quite easily. Exactly two letters the same, or two digits the same but not both. So one of the cases will be, well, two letters same, but digits different. Makes sense, right? So visualize it, please. So we are looking at or XXY, 1, 2. So this is what you want, right? Okay, this is one of the so-called codes that you really want. Okay, so that's cool. How do we do that? Well, it turns out that we talked about it just now. So 26, choose 2 first, and then I need times 2 because of the XXY, XYY, and then I need times 3 factorial over 2 factorial. All right, but this time around, I want the 2 digits to be different. So with the 2 digits to be different, there will be 9p2. Correct or not? Okay, now let's go through this. Well, I understand that a lot of you actually think of the cases, but you get the numerator wrong because you can't do the permutation. Okay, so one more time. This part, just now we talked about it already. And when I talk about it, when I went through it, all yeah. Okay, so it's the same. Okay, 26 choose 2 because you need 2 different letters still, X and Y. Times 2 because it's either XXY or XYY. One of it is the double one, right? So you need to times 2 because you got 2 such cases. Can? Okay, just now we actually went through this. 3 factorial over 2 factorial because XXY can be XYX, can be YXX, you know, that kind of thing. Yeah, so the permutation. So there you go, this is it. The only thing that we didn't talk about is the digits. But I think this is okay. 9p2 settles it. Right? 9, I choose 2, I permutate the 2. Okay? So this is the probability of a case 1, which is 26 cubed times 9 squared, and we are done. Okay? Okay? Alright, so you realize that this 26 cubed and 9 squared is very annoying, right? So from part 1 until now, it's haunting you. Okay? So if you cannot get it from part 1, you're quite dead. Alright, now then we talk about case 2, right? Okay, case 2, which again, many of you actually identified correctly. Letters different. 2 digits same. Not hard. A lot easier. What do I mean? Well, basically, you're talking about X, Y, Z, 1, 1. If you visualize it, it looks a bit like this. I realize that quite a lot of you didn't really write down a sample or what we call an example of what you want. I think this helps a lot, no? At least for me. Okay, when I see this, I know what I'm hunting for. And I can clear all my questions. I want to include this or not. I want to include that or not. Okay, so this one turns out a bit easier because it's 26p3. Right? Settles it. I need 3 different letters, what? Okay, 3 different letters, 26p3, and order matters. Okay, but the 2 same digit, well, think about it, it's also quite easy. It's actually 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, right? Also 9, choose 1. I saw at least one student from other class, 9p1. Okay, 9p1 is the same as 9c1, right? Because the 1 factorial doesn't make any difference. But when you write 9p1, it gives me the sense that you don't understand the difference between p and c. Okay, and I feel a little bit uncomfortable if I don't correct you. Okay, so 9c1 should be the more correct meaning, right? 9p1, like, I don't know whether is it you are thinking the right thing or not, but you should know it's the same. And we get this. More often than not, students actually get these 2 cases. I would say most common, and they start calculating. Okay, and the surprising thing, that's what will surprise you. Okay, you actually get the answer. Okay, let's try. 26p3 and p2. Right, so the case 1 first. Times 3, and then times 9c2. Right, 9c2. Right, wrong. 9p2. Great. 9p2. Okay, right. So that's the case 1's numerator, yeah. Okay, plus case 2, 26 p3 times 9. Okay, we're done. Right, times 9. All right. So that is the plus the case 2 divide by 26 cube times 81, which is a 9 square, right? Yeah, 19723. I probably just want to copy and paste this entire thing. 0.19723 23 what? I cannot remember phone numbers for nuts. 23865. Okay, 866 good enough. Round off the 3SF, you get the answer. Okay, and many people, in fact, some school teachers tell you the answer is like that. Okay? Now you probably guess, okay, no, nothing wrong, what? Until some students start asking this question, like, Mr. Ang, I have a case 3, Include or not? And then you can go on, Include or not? So it's a very hard to answer question, because if you check the answer at the back, this is the correct already. Right? And you go like, it's correct already, what? What's the big deal, man? I mean, you add on to confirm wrong, right? So it turns out that you probably think that no need. Okay? But if you read, I would say it's not actually very clear cut. Exactly 2 letters the same, or exactly 2 digits the same, but not both. Does this fall inside what you want? Some people argue it's not, because the question obviously say you want 2 letters the same. This is not 2 letters the same. This is 3 letters the same. So how you want to define that? So then some people will say, well, actually, 3 letters the same is a subset of 2 letters the same. So when you talk about that, you're actually talking about this as well. So how do you argue that? The funny thing, I won't say funny, okay, but the thing about this you probably want to know is that some school teachers added this in as part of the solution. Some school teachers don't, because the answer is like that. It turns out that the probability are so small, it doesn't affect the 3SF. Okay? But we know that we need to, because we have another method. Right? And the answer is, well, of course the same, but if you pay attention, 1974. Okay? What we have here, 1972. Okay? So it tells me that the blue color one is a bit of lacking. Okay? And the lacking is probably these 2 cases that we're talking about here. Okay? We try to get them and see if we add up to the 1974, right, instead of 1972. Okay? So how do we calculate this? Like I say, this one you can argue until the cows come home. Some people argue until they say that you should not include because of the English. Right? Some people argue until that you should include. The way I argue will be because if I do it another method, it doesn't seem to tally. Right? So the other method can't be wrong. So therefore, I think mathematically we need to include these 2. That's the reasoning. I think which is more sound. All right, but anyway, let's try to figure out all this and we try to add up as well. This one will be easy because you just 26 choose 1. No choice, right? 26 choose 1. And then 9p2 divide by 26 cube times 9 square. Okay? And then we get this answer. I don't know what is it. This one will be 26c1, 9c1 over 26 cube times 9 square, which is actually quite easy. It's just 1 over 26 square times 9, which is, you can imagine how small it is, right? And which is why you probably guess that it doesn't affect the answer. I copied this down already. Let's work out the other 2. Hopefully it adds up to be the blue color answer that we got earlier on, which is the 1974. Okay, let's see if it works out that way. Okay, see the problem with this arguing, right? Okay, let's not include this, and then we try this. Okay, one more time. Just to make sure that we really get the English right. Okay, so okay, we tried that one. Okay, so it's actually what is it? 26 square times 9, right? So 1 over. And so this magic number plus 0.19723866. Yeah, 194. So there you go. So somehow this is not included, right? And again, you see the argument. That one is okay, but that one is not. All right. So that's the missing case. All right. And again, I hope you see the difficulty in arguing why this one should be included when the English sounds like that. And if this is included, why that is not included? It's quite hard to argue. Okay. So my favorite way to solve this would be this. Okay. Because it makes the arguing, or rather makes the answer more clear cut. I want, I don't want, whatever, I just use formula. Can't be wrong. Okay? Understand? This is I would say the more accurate answer on 1974. Okay? But I mean, we get it, right? So that's the thing about cases. You see, cases always gives us the worry about missing out something. And this question is very annoying because if you miss out, you can't tell. Okay, all right, can? So interesting, A-level question, 3 marks only. All right, how much time we spend is not worth it in exam. Okay, come, let's move on to the last one. It should be easier.